are performing operations with complex numbers, which is where we are introducing a whole nother set of numbers. And we will see complex numbers anytime we take the square root of a negative number, okay? So in this case here, we have x squared equals negative 16. So if we were trying to solve for x in this case, we would have to take the square root of negative 16. So if we were to take the square root of negative, we would have no solution, and set real numbers, okay? So the reason for this is that we would have an imaginary number. So the imaginary unit, which is represented by an I, can be used to describe the square roots of negative numbers. So I equals the square root of negative 1, okay? And I squared equals negative 1, okay? So if I was to take I and square it, that would be the same as saying the square root of negative 1 squared, right? That would undo your square root, leaving you with negative 1. And that is why I squared equals negative 1. So anytime you see an I squared, always substitute negative 1 for your I squared when simplifying. Okay? You can always substitute negative 1 in for I squared. Okay? So let's take a look at a couple of examples and how we are going to apply the imaginary unit into our solutions. So if we have the square root of negative 9, we can simplify this as the square root of negative 1 times 9. That way we can simplify the square root of 9. Okay? If we wanted to simplify this even further, we could have two radicals. The square root of negative 1 times the square root of 9. Okay, the square root of negative 1, as we saw above, equals your imaginary unit I, and the square root of 9 equals 3. Okay, so I times 3. And how we write this is we'll write this as 3I, where the imaginary unit follows our coefficient 3. Very similarly, if we were to do number 2 here, we could simplify negative square root of 3 by factoring it as negative 1 times, and then we might as well factor 12 as well, so we can simplify as 4 times 3. Okay? We simplified this way because 4 is a perfect square. Okay? Let's separate our radicals. So the square root of negative 1 times the square root of 4 times the square root of 3. We can simplify the square root of negative 1 as I, the square root of 4 as 2, and we cannot simplify the square root of 3. Okay, let's put this all together. So we have 2I square root of 3. Okay. I will leave number 3 for you guys to try on your own. In a case like number 4, when we are multiplying imaginary numbers, just like radicals, multiply your coefficients and then multiply your imaginary units. So we have negative 3 times 8, which gives us negative 24, times I, which is just I squared. Remember, when you have an I squared, you can always substitute in a negative 1. So you have negative 24 times negative 1, which just equals a positive 24. Okay? in an example like number 5, first, order of operations. Take care of both of your radicals separately. So before multiplying them together, we can simplify the square root of negative 6 as I times the square root of 6. Okay, I simplify it this way because, like we said above, the square root of negative 1 is I. So in order to undo your negative under your radical, just multiply it by I. Same goes with our negative 10 here. We have I square roots of 10. At this point, multiply your coefficients and multiply your radicals. I know this kind of looks like a B or something like that. It's actually a 10. So I times I gives us I squared times the square root of 6 times 10, which is just 60. Okay, let's simplify our radical. Simplify our I squared. I squared turns into negative 1 and a perfect square factor of 60. We could make that 4 times 15. The square root of 4 is 2. So that gives me negative 1 times 2 times the square root of 15, which ultimately simplifies as negative 2 times the square root of 15. Okay? I know these seem a little odd right away here, yet with a little bit of practice, you will start picking these ones up. The math isn't overly complex, it's just a brand new concept. Okay, try number 6 on your own as well. Remember, for number 6, you will have to FOIL. Well, no, you don't necessarily have to FOIL. You do have to expand your square here and then multiply your coefficients and radicals from there. Okay? We'll take a look at that one in class, though. All right. Scrolling down to a couple of quadratic questions here. Okay. Let's do one of these for now, and then we'll save the other ones for class. Okay, let's take a look at, let's actually do number 8. Okay, so I have x minus 3 squared equals negative 12. Okay, so if we were trying to solve for x, we would first have to undo our square. So in order to do that, we could take the square root of both sides. Okay, the square root of x minus 3 squared is just x minus 3. And then that equals, remember when you take the square root, you have to have plus minus the square root of negative 12. Okay, now our only job here is to simplify the square root of negative 12, since we can't have a negative there. Okay, so you have x minus 3 equals plus or minus the square root. Let's factor this. And we already did this above. Negative 1 times 4 times 3. From here, simplify. X minus 3 equals plus or minus square root of negative 1, which is I, the square root of 4, which is 2. So actually, let's erase. Let's make that 2I to write it properly. Square root of 3. Okay, if we were trying to solve for x here, we would have to add 3 to both sides. And remember, if we are going to add 3, let's add it in front of our plus minus there. So we have x equals 3 plus or minus 2I square roots of 3. Okay, and that is our final answer there, number 8. Okay, so for the sake of time, let's skip 7 and 9. We will be looking at these in class, so come with it done so you can ask questions. All right, so all of this that we've been working with falls under the set of complex numbers, which is represented by a big capital C. A complex number is a number that can be written in the form a plus bi, where a and b are real numbers and I is just your imaginary unit. So as it says here, a is called the real part, bi is considered the imaginary part of the complex number. When writing complex numbers, the real part should be written first. That is just standard form, okay? Real part, then imaginary. We already talked about that a little bit above. Two complex numbers are equal if and only if their real number is the same, so the first part, and their imaginary part is the same, which would just be looking at those coefficients. When adding or subtracting complex numbers, you combine your real parts and combine your imaginary parts. Okay? So if we were, really a couple side notes about complex numbers. Okay? First of all, every number is a complex number. Okay? Like we talked about, the abbreviation is a capital C. If we were to break down our complex numbers into a set here, as it says, we have our A plus BI. Those are our complex numbers. We can break this up into two separate groups. Okay? We have our real numbers, which is what we looked at earlier this year. And we have our imaginary numbers. If I can spell. Okay? Where our real numbers is when you have A plus 0, I. Okay? Where you have the real number part, but you don't have the imaginary number part, right? Those are those sets that we talked about, 0, whole numbers. Integers, rational numbers, real numbers, okay? Those are all of the sets of real numbers that we talked about earlier. Okay, in our imaginary numbers, you have your A plus BI, where you actually have the imaginary part attached. But ultimately, this all falls under this one big umbrella of the complex number. So this is the number system we've been working at, the real numbers. We are now adding the imaginary number system, but ultimately it's important to remember this is just all under complex numbers, okay? If you have questions about this, make sure to ask it in class. This is an important realization here, okay? All right, so like we talked about, we can perform operations in the complex numbers. That's not a problem at all, even if they are imaginary numbers. So for an example like number 10 here, we can add these together. Remember, you need to add your real parts and add your imaginary parts. So if we have 8 minus 5i plus 2 plus I, you do not need parentheses here. It's just not necessary because you will add your real number parts, which is your 8 and your 2, and you will add your imaginary number parts, which is your negative 5 and your 1i. Okay, so 8 plus 2, that gives me 10, minus negative 5 plus 1 gives me negative 4i. That's all there is to it. Make sure you write it in this form, okay? Remember, your standard form is A plus BI. You always write it this way. Okay, I am, let's see. Let's skip number 11 and let's skip number 12 as well for now, just for the sake of time. Okay, for number 12, you are foiling. Remember what happens when you multiply your negative numbers. What happens when you have I squared. And for number 11 here, you are just adding again. Okay, we'll take a look at those for sure in class, but give them a try. When dividing an imaginary number cannot be left in the denominator, similar to radicals in the last lesson. So to eliminate an imaginary number in the denominator, multiply by the complex conjugate. Okay, complex conjugate is just like the conjugates that we were talking about in the last lesson, where all we are going to do is flip the sign between your real part and your imaginary part. So let's take a look at number 13. Right now, our solution has an imaginary in the denominator. So let's multiply both your denominator and your numerator by the complex conjugate. So we have 1 minus I over 1 minus I. Okay, let's distribute 5 in the numerator. So 5 times 1 gives us 5, minus 5 times negative I, which is negative 5I, all over, and then we must FOIL our denominator. So 1 times 1, 1, 1 times negative I, which is negative I times 1, which is I times negative I, which is negative I squared. Okay, right away you can identify that our negative and positive I are going to cancel. Okay, let's go ahead and simplify. So 5 minus 5I, not a lot we can do there. But in our denominator, we have 1 and we have I squared. Remember, I squared becomes negative 1. But since we have a negative out in front, that would give us minus negative 1. Okay, which obviously you guys know that turns into addition. So we can ultimately simplify this as 5 minus 5I over 1 plus 1. Just gives us 2. Okay, number 14, very similar process. Give it a try on your own, and we'll look at it during class. Like number 15 here, this is a little bit of a different case. Okay, we have 3I in the denominator. This does not fall under our complex conjugate. Yet we still can't have, well, it does fall under our complex conjugate. Yet in this case, it's just a little different since we don't have that real part. So in order to undo our I in our denominator, all we need to do is multiply by I over I. Okay, because that will get rid of our imaginary part here. So let's go ahead and multiply. 2 plus I times I. Ultimately, we would just be distributing I in this case. So 2 times I gives us 2I plus I times I, which is I squared, all over 3I times I, which is just 3I squared. Okay, let's go ahead and simplify. 2I, not much we can do there as of now. I squared, remember we can just substitute a negative 1, all over 3 times I squared, which is just 3 times negative 1. Let's go ahead and simplify this. Okay, in our numerator here, remember, standard form is to write our real part first. So let's write this as negative 1 plus 2I. Okay? All over 3 times negative 1, which is just negative 3. Okay, at this point, you could leave your answer just like this. That's totally fine. But if we were in that case that we don't want to leave any negatives in our denominator, we would just multiply everything by negative 1. So flip the sign on 3, flip the sign on our 1, and then flip the sign on our 2I to make that 1 minus 2I all over 3. Like I said, I'm not super picky about that last step, yet for formality's sake, we will do it. Okay, I tried to keep this lesson somewhat short, yet there was a lot to cover here. So hopefully you can give those other ones a try on your own. Come to class with questions, but more than likely we'll be going over plenty of examples together. Okay, thanks for watching.